Good morning, everyone. In our last class, we have discussed about parity bits, weighted codes, unweighted codes. Okay. So, in today's class, we are going to discuss about different postulates in Boolean algebra and De Morgan theorems, logic gates, and also universal gates. Of course, universal gates are also comes into the logic gates. Okay. So, in our last class, we have discussed about what weighted codes and unweighted codes, and the conversions also over. Once I would like to revise last class topics. Okay. What is the base or radix of binary number system? That is 2, and base or radix of hexadecimal number system 16, base or radix of octal number system, that is 8, and base or radix of decimal number system, that is 10. So, how many number of digits are there in decimal number system? 10, 0 to 9. What are the digits in binary? 0 and 1. What are the digits in hexadecimal system? 0 to 9, A to F. What are the digits in octal system? 0 to 7. So, these are the different binary number system we are used in our digital electronics. So, here human being can understand the decimal system, and the system can understand only the hexadecimal binary number system. Mostly microprocessor digital clocks works with hexadecimal number system, and some other codes also there: ASCII code, gray code, XS3 code. So these are the different codes are used in our digital electronics, microprocessors, microcontrollers, digital clocks, etc. So in today's class, we are going to discuss about different postulates in Boolean algebra. So it simply means rules. What are the different rules we are used in Boolean algebra? So before going to that, what is meant by variable? What is meant by Boolean variable? So see here, how many number of Boolean constants are there? Only 0 and 1, our binary numbers. So already I said you, how many number of binary bits are there in our digital electronics? Only 0 and 1. So these 0 and 1 are considered as Boolean constants. So these 0 and 1 are considered as what? Boolean constant. And this, why these variables are called Boolean variables? Why? Means these are invented by a mathematician named George Boole. So this is the name of the scientist who found the Boolean variables, George Boole. So that according to his investigation, so we allot his name to these variables, Boolean variables. How many number of constants are there in Boolean variables? 2 constants are there. What are the 2 constants? 0 and 1. So see here, while coming to the operators, constants are 0 and 1, and Boolean operators are OR operator and operator, not operator. Here, OR operator is just considered as addition, for the purpose of addition, not addition but for the purpose of addition. And simply AND operator indicates product function, and not is used to indicate complementing function. Okay. And while coming to the postulates, so how many number of constants are there? 2 constants are there. What are the 2 constants? 0 and 1. And how many number of Boolean operators are there? 3. AND gate or not. And now while coming to the Boolean postulates, postulate means it's a rule, it's a law. So some different laws are invented by a Greek scientist. So according to his name, these rules are called Boolean postulates. Who invents these postulates? Boole, George Boole. So according to his name, these laws are called Boolean postulates. So see here, so first postulate in Boolean algebra is commutative law. Already we have very good idea according to our maths. A plus B is equal to what? B plus A. So in general also A plus B is equal to B plus A. In Boolean postulates also is equal to A plus B is equal to B plus A. How? Once see here. For example, in decimal, 3 plus 2 is equal to how much? 5. So 2 plus 3 also is equal to how much? 5. Means a plus b is equal to b plus a. So likewise, once see, if a is 1, b is 0, a plus b is equal to b is 1, a is 0. So finally we are getting both are same. Means by changing or interchanging the Boolean constants also, variables also, we are getting equal sum. This indicates what? Commutative law. So total how many number of commutative laws are there? 2 commutative laws are there. First one is a plus b is equal to b plus a, and second one is a into b is equal to b into a. So once we also check second law. So if a is equal to 1, b is equal to 0, once see, a into b is equal to b into a. 1 into 0 how much? 0. 0 into 1 how much? 0 only. So according to these Boolean variables, a plus b is equal to what? B plus a. ab is equal to ba. These two laws are under comes into commutative laws. Okay. And while coming to the associative law, a plus b plus c is equal to a plus b plus c. So while coming to this, a plus b plus c is equal to a plus b plus c. And while coming to the next thing, a plus b is equal to, so this is the proof. Already I told you by taking 2 variables, but all these are the 4 combinations. So how many number of variables we are having? 2 variables now, 0 and 1. One see. So cos of 0 and 1, 2 variables, how many number of combinations we are getting? 2 to the power of 2 is equal to 4. So how many number of combinations we are getting? 4 combinations. 0, 1. 2 to the power of 2 is equal to how much? 4. So a plus b, b plus a. So once we check, a 0, b 0, a plus b 0, b plus a also 0. 0 plus 1, a plus b. So 0 plus 1 and 1 plus 0. 0 plus 1, 1, 1 plus 0, 1. Next 1 plus 0 same, 1 plus 0 and 0 plus 1. 1 plus 1, 1, 1 plus 1, 1. Is it clear? So this is a proof for commutative law by taking LHS and RHS. Now we prove LHS is equal to RHS. Is it clear? So next, while coming to the next one, a into b, second commutative law, is equal to b into a. So this is the truth table to prove the second commutative law. So here also same, a into b is equal to 0. Again b into a also 0. A into b all occur. Why? Because if any of the input is 0, the output is 0. Why? Because is all the 3 combinations, a into b, 3 combinations having 0, so that it is also like that. And see, while coming to the proof of associative law, a into bc is equal to ab into c. A into bc is equal to ab into c. And see here, a into bc is equal to ab into c. Here it is LHS and this one is RHS. So this row indicates LHS and this row indicates RHS. So once I would like to prove only one first variable, a middle. 0 into next 1 into 1. 1. 0 into 1, again it is equal to 0. Next combination AB, 0 into 1, 0 into C. Again 0 into 1, 0. So in this way we can prove our associative laws also. So next is A plus B plus C is equal to A plus B plus C. So ABC, A plus B, A plus B plus C. So one C. So see here, A plus B plus C. This is RHS term. So here it is this term, A plus B plus C is here RHS term, and here it is LHS term. So A plus B how much? 0. Plus C 0. So A plus B plus C also 0. Same here also, B plus C how much? 0. 0 is added to A. Finally we are getting 0. So in this way all 8 combinations. Why? Because here 3 variables are used, A, B, C. In previous table only 2 variables are used, 2 to the power of 2 is equal to 4 combinations occur. But here 2 to the power of 3 is equal to 8 combinations. So that's here 0, 1, 1, 2, 3, 4, 5, 6, 7, 8. Our table contains 8 columns. Why? Because how many number of variables are there? 3 variables are there. A is one variable, B is one variable, C is one variable. So according to the truth table, total how many number of combinations occur? 8 combinations occur. How many number of variables are there? 3 variables are there. So in 3 variables A, B, C, total possible combinations are 8. Why? Because 2 to the power of 3 is equal to 8. Okay. So next, while coming to the next law, distributive law. A into B plus C is equal to AB plus AC. So distributive law. According to distributive law, so AB plus AC. A into B plus C is equal to AB plus AC. Say you take 3 variables to prove this. You do this distributive law proof before seeing the slide. Take A, next B, next C1, C11. 3 variables A, B, C, 0, 0, 0. So you write all 8 combinations. Next you write first B plus C, next A into B plus C. You draw the table like this. Next you write AB, next you write AC, next you add AB plus AC. So in this way you form the table. It is very easy. Next also A plus BC is equal to A plus B into A plus C. So next A plus A is equal to A into A is equal to A. So how it is? Identity law. A plus A is equal to A. Is it correct or not? For example, if I choose A is equal to 1, 1 plus 1 is equal to 1 only. Okay, A plus A. For example, if I consider A is equal to 0, 0 plus 0 is equal to 0. Is it clear? Okay, next, A into A is equal to also A. 1 into 1 is equal to 1. 0 into 0 is equal to 0. 1 into 1, 1. 0 into 0, 0. That means what? A into A is equal to A only. According to identity law, same numbers, identical numbers, either product or summation is equal to that number only. Identical number summation or product is equal to that particular number only. And see here, while coming to here, distributive law, truth table. So proof of distributive law. Already I told you, you form A, B, C, 3 variables are there, and once you take the product of A and B, and you take the product of A and C, so finally A into B plus C, AB plus AC. LHS is equal to RHS. Already I explained this. So next law is redundance law or absorption law. So why these two laws are called redundance or absorption laws? Here the expression is going to simplified. Initially maybe the length of expression is long. After doing it, the length must be reduced. So see here LHS side it having A plus AB. 2 variables are there, product function is there, sum function is there, but finally it is equal to A only, RHS side. So that's why here the expressions must be reduced in output, so that it is called redundance law. Means these expressions A plus AB is equal to, for example, any expression having like this A plus A, B plus A plus A. So this whole expression is simplified by putting simply A plus A according to redundance law. But according to redundance law, all A is equal to only single A. Means here the expression must be simplified, reduced. A lengthy expression is simplified into a single term. So that's why the name of this law is called redundance law. And while coming to the next one, see here, A into A plus B. How it is getting means, already I told you, identical numbers is equal to single. A into A and then A, B. A into A is equal to A. Next A plus B. Here A is common, 1 plus B. Next A is equal to 1 plus B is equal to 1. So A into 1 is equal to again A only. So in this way these two laws are called redundance laws. Which two laws? A into A plus B is equal to A, and A of A plus B is equal to also A. So next see here, while coming to the next law, A into B plus A into B is equal to what? A only. A into B plus A into B is equal to A into B only. Next, A plus B into A plus B is equal to what? A plus B. Here some small mistake is there. So here A into B plus A into B is equal to how much? A into B. A plus B is equal to how much? A plus B. These are also under comes into the identical laws. So next here, while coming to the second one, 0 plus A is equal to 0 only, not 0. 0 into A is equal to 0. 0 into A is equal to 0 into A is equal to 0, but 0 plus A is equal to A. 0 into A is equal to 0. 0 plus A is equal to A only. Okay, so according to this law, redundant laws, all these are called. 0 plus A is equal to means these laws are used to simplify the Boolean expressions. Lengthy Boolean expressions are reduced into a simplified version by using these laws. Okay, next also there, 1 plus A is equal to 1. 1 into A is equal to A. Once check. 1 plus 0 is equal to how much? 1 only. 1 plus 1 is equal to how much? 1 only. So that 1 plus A means whether it may be 0 or it may be 1, is equal to how much? What we are getting? A. Why? Because here 1 plus A, why it is called A means A may be either 0 or it may be 1, but finally we are getting 1 only. Means by adding something to 1, we are getting 1 only in Boolean postulates. According to Boolean algebra, by adding something to the 1, we are getting the sum 1 only. But by multiplying something with a variable, we are getting that variable. For example, 1 into 0, we are getting what? 0 variable we are getting here. 1 into 1, we are getting what? 1. But not all the time 1. But in addition, we are getting 1. In multiplication, we are getting that variable. Is it clear? Okay. So next, while coming to the next one, A bar plus A is equal to how much? 1. Is it correct or not? Once we check, see here, A bar. For example, I will consider A is equal to 1. A bar plus A is equal to 1. A is equal to 1. So A bar is equal to 0. I consider A is equal to here 1. 1 bar is equal to 0. So 0 plus 1 is equal to 1. Is it clear? So A bar plus A is equal to 1. Next, A bar. Now I consider A is equal to 1. A is equal to 1. If A is equal to 1 means A bar is equal to 0. What we are getting? 0 only. That means what? Complement of that particular variable is multiplied with the same variable, approximately it is equal to 0. Means B into B bar also is equal to 0. A into A bar also is equal to 0. But A plus A bar is equal to 1. B plus B bar is equal to whatever it may be the variable. By adding with its complements, we getting 1. By multiplying it with its complement, we are getting 0. And see here, A plus A bar is equal to A plus B. How it is possible? Once check. A, you are taking common A, 1 plus. Here we are getting A bar B. So no possibility of taking complement. So A plus A bar B. What we are taking common here? A plus A bar. Okay, we are writing like this. This variable is written as simply once you check A plus A bar, A plus 1 plus A is equal to A and plus A bar B. So in this way we can simplify the expressions. And A double bar is equal to what? A only. So this is the table for previous one, A plus A bar A B. Next one is called what? Principle of duality. The dual of any Boolean expression is obtained by replacing plus by and vice versa. and by replacing every 0 with 1 and vice versa. Means what? In any Boolean expression, plus is replaced by minus, minus is replaced by plus. That means 0 is replaced by 1, 1 is replaced by 0. Simply the equation is like this. For example, A plus B and B plus A. For example, here A it is 1 and B it is 0, it is 1 and 0. In dual, 0 is replaced by 1 and 1 is replaced by 0. So in this way we can simplify the expressions. And see here, next topic is, so till now Boolean postulates are over. So these Boolean postulates are used to simplify the Boolean expressions. These are very useful in overall digital electronics. And while coming to the logic gates, the name itself indicates some logic is there in every operation, every function. That's why these are called logic gates. And all logic gates having only one output, but one or more than one input is also there. So that is the common nature of logic gates. So many logic gates are there, basic gates are there, universal gates are there. How many number of gates are there? Basic gates are there, and universal gates are there, and also special gates are there. So total 7 gates are there. Among 7, basic 3 and or not, universal 2 and nor, special 2 XOR and XNOR. So total 7 logic gates are there. Among 7 logic gates, okay, all gates having single output, all gates having single output and only one input. All gates are having single outputs, but more than one input also there. Inputs are more, but output is only one. So basic gates are there, combinational gates are there, OR gate, AND gate, NOT gate. And see here, basic gates are 3, OR and NOT. The combinational gates are 2. Why these are called combinational means these gates are erased from basic gates. So how many number of basic gates are there? 3 and or not. So by combining and plus not, we are getting NAND gates, and by combining and not or and not, we are getting NOR, and not, we are getting NAND. So why these are called combinational means by combining basic gates, 2 basic gates, we are getting these gates. That's why these gates are called combinational logic gates. And these gates are also having one more specific name. These gates are called universal gates. So why these gates are called universal gate means with help of these gates, by using these 2 gates, NAND gate and NOR gates, any circuit in the digital electronic must be certified. Means what? Realized. AND gate must be designed by using 2 NAND gates. That means without using AND gate function must be produced. Without using OR gate, by using NAND gate output will be produced. So that indicate what's without using that particular gate, that function provided. By using NAND gate function we are getting, OR gate function and also NOT gate. By using NOT also, these 3 functions must be produced. That's why these gates are also called universal gates. What is the name of these 2 gates? Universal. And why these are called combinational gates? Why means these are erased from basic gates. By combining the function of 2 basic gates, we are getting 2 gates, NAND gate as well as NOR gate. And the next 2 gates are there, exclusive OR gate and exclusive OR. These 2 are called special gates. Okay, see here the truth table and the logic function of OR gate is there. So first one, this is the symbol of OR gate. So this is the symbol of OR gate. So here we are considering two input OR gates. Of course, OR gates are available 2, 3, 4, 5 up to infinity. But now here we are saying only two input NOR gate. How many number of inputs are there here? Two inputs. But the input number of inputs to the OR gate is not restricted. Maybe increased according to our requirement until infinity. But in our slide it contains two input. In our syllabus also they are asking about only two input OR gates. So what are the inputs here? AB. What is output? A plus B. So finally see here, by using two variables, how many number of combinations we are getting here? 4 combinations are there. What are the 4 combinations? 0, 0, 0, 1, 1, 0, 1, 1. So by using two variables, two inputs A and B, how many number of combinations we are getting? 4 combinations. And output Y is equal to what? A plus B. This OR gate will provide the function of addition, that is y is equal to a plus b. Once we check 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 1. But here when some logic is there, why this is called OR gate? What is the logic? Of course it produces addition function, binary addition. But some logic is there. Even though without doing like this 0 plus 0, 1, 0, for example, if we are considering 10 variables A, B, C, D, 3, y is equal to A plus B plus C. So then how can we so by without calculating we write the answer. How can? See here, if any of the input is high, any of the input is high, the output is high. ఏ ఒక్క అవుట్పుట్ హై ఉన్న ఇన్పుట్ హై ఉన్న అవుట్పుట్ ఎలా ఉంటుంది? హైయే. సో దిస్ ఈజ్ ద ఫంక్షన్ ఆఫ్ OR gates. What is the function of OR gate? OR gate A, B. Y is equal to what? A plus B. Y is equal to what? A plus B. So by taking the variable A and B, Y is equal to what? A plus B. So what is the logic involved here? If any of the input is high, of course also 1. 10 zeros are there, only 1 1 is there, also the output is 1. Means if any of the input is 1, the output is high. 1 means high. Here 0 is termed as low and 1 is termed as high. Okay, if any of the input is high, the output is high. And see here next, AND gates. So this is the symbol of AND gates and this is the IEEE symbol. Why here we are drawing IEEE symbol? Means IEEE symbol is the standard symbol. It indicates all possibilities. How many number of inputs we are considering here? 1 up to n numbers. 1 up to n numbers. Maybe 1, 2, 3, 4, 5, 6, 7, 8 up to infinity also. Finally we are getting the output is the summation of the input variables. Okay, and see here which gate it is? AND gates. Which gate it is? AND gate, A and B. So it consisting of two variables A as well as B. Here it produces the function of product. But what is the logic involved in here? It is, if any of the input is 0, the output is 0 simply. So one input is 0, the output is 0. 0 into 1, 0. 1 into 0, 0. Only when all the inputs are high, the output is high. When the output is high, only when all the inputs are high, only the output is equal to high. So this is the truth table. And once again, what is meant by truth table? Every second I call truth table, truth table. So what is meant by truth table? So truth table means any table that gives the relation between the input variables and the outputs, then the table name is called truth table. And it holds all the values A, B. Okay, all combinations. all combinations, all possible combinations of variables. How many number of variables are there? A and B. So y is equal to A into B. If any of the input is 0, automatically the output is also 0. Then when we are getting the high outputs, when all the inputs are high, then we are getting the output is high. And see here, this is the truth table of what? NOT gates. So here the NOT gates, here the NOT gate give the function of what? Complement function. So it give the function of what? Complement function. So complement means what? Once see, if A is equal to 0, if we are applying the input A, then what we are getting? A bar. Okay. Means what? If A is equal to 0, we are getting 1. If A is equal to 1, we apply, the output is 0. Simply it will give the complement function. If input is A, the output is A bar. That means if we are getting 0, we are getting 1, complementing, inversing. If we apply 1, we are getting 0. If we apply 0, then we are getting 1. So here the truth table is there. A is equal to 0, y is equal to A bar, that means 1. If A is equal to 1, finally we are getting A bar is equal to 1. And see here, while coming to the NAND gates, this is the combinational gates. It is the combination of AND plus NOT function. So once see here, NAND function, this is the combination of AND also plus NOT. In AND function, any of the input is, in AND function, any of the input is 0. The output is what? 0. So till this it is okay, 0. But if any of the input is 0, we are getting 0, 0, 0, 0, 1. But it is complemented in AND gates. So that by complementing the output, we are getting what? 1, 0, 0. Okay. So next, see the truth table once. I consider two variables A and B. If both are 0, we are getting 1. Why? Because here we are taking the complement function of AB. A0, B0, we are getting A into B also is equal to 0. But here we want AB bar. AB bar means what? 1. So in this way, the truth table will give the relationship between the variables. But here the output of NAND gate is exactly the complement of what? AND gate. NAND gate output is complement of AND gate. So next one NOR gate. The output is high only when all the inputs are high. So see 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0. So here which gate? Here we are using NOR gate. So NOR gate means what? OR gate plus NOT gate. So what is the function of NOT gate? Complement function. What is the logic of OR gate? If any of the input is high, the output is high. But in NOR gate, it is complement. If any of the input is high, the output is low simply. Here the output is high, so the output is low. Why? Because it is the complement function of OR gate. So according to the logic, OR gate gives any of the input is low, the output is high. But here any of the input is low, any of the input is high, we are getting. So here B is high, so 0. A is high, so we are getting 0. Both are high, we are getting 0. Means what here? Any of the input is high, the output is low. Any of the input is high, the output is low. And see here, this is the special gate, that is exclusive OR gate. So here which logic is there? So this is the symbol and this is the IEEE symbol. So here IEEE symbol also having only 2 inputs. Why? Because exclusive OR gate is here it is designed with 2. Of course it may be increased to inputs more than 2 we are having. A, B, A is equal to 0, B is equal to 0, 0. both inputs are same, we are getting 0. Both inputs are different, we are getting 1. But you see, the output is high for different output. This logic is not suitable for all truth tables. Means if the truth table having 2 inputs only, this logic is okay. If the inputs are different, the output is high. But if the truth table contains more than 4 variables, 0, 0, 0, 0, right, 1, 0, 0, 1, 0, 1, then what logic implemented here? For the odd number of inputs, the output is high. For the even number of inputs, the output is 0. So this is the logic involved in exclusive OR gate. So what is the logic involved in exclusive OR gate? If the odd number of inputs are high, the output is high. For even number of inputs are high, the output is 0. Okay, so this is the truth table of exclusive OR gate. And see here, this is the see here. So this is a symbol and this is a logical expression. So here this circle and place over or circle surrounds place is called exclusive symbol. So here A into B, 3 input OR gate, 1, 2, 3 input AND gate, n input OR gate. So here n inputs are their output. Maximum number of input possibilities for 4 input OR gate. So 4 input OR gate, how many number of, already I told you. So how can we find out possibilities? If it is a 4 input AND gate, you take 2 to the power of. So to calculate possibilities, we should take first 2. Why? Because 2, 0 and 1, 2 variables are there. So here how many number of variables are there here? Input 4 input. 2 to the power of 4 is equal to how much? 16. So how many number of possibilities are there here? 16 by using 4 input variables. So how can we calculate this? By taking powers. Inputs are considered as powers of 2, then we calculate the possibilities. So simply number of possibilities is equal to 2 to the power of inputs. Here n is equal to number of inputs. 2 to the power of n is equal to number of possibilities. So 2 to the power of n, here n is equal to what? Number of inputs. Then we are getting what's number of possibilities. Here we are having only 4 inputs. So 2 to the power of 4 is equal to how much? 16. So in our previous slide, 2 to the power of 2, only 2 variables are there. We are getting 4, means our truth table having 4. And see, a certain 3 input logic gate has 3 inputs. A is equal to 1, B is equal to 0, C is equal to 0. A certain 3 input logic gate, certain its output is y is equal to 1, then the gate is, so see here you checked out 16, previous one it is okay. Now A is a certain 3 input, some logic gate is there now. So it having 3 inputs, A1, B0, C0, if its output 1. So which logic is there here? Once you check first, A1, B, A1, B0, C0, but output is 1. He said the logic. So any of the input is high, the output is what? 1. So this logic is utilized for OR gate, and also same it is utilized for NAND gate also. So that it may be either NAND gate or it may be OR gate. Okay. One more question is there. In a 3 input NOR gate, the number of states in which the output 1 is equal to 3 input NOR gates, the number of states, ఎన్ని స్టేట్స్లో అవుట్పుట్ 1కి ఈక్వల్ ఉంటుంది 3 ఇన్పుట్ నార్ గేట్స్. సో వన్స్ see here in 3 input NOR gate 0, 1, So in 3 input NOR gate, these are the combinations 0 0 1 0 1 0 0 1 1. Okay, you leave it up to 1 1 1 we are writing. So in number of states in which output 1 is equal to what? Output 1 is equal to, in how many number of states output is equal to 1? So only 1. Why? Because in NOR gates the output is equal to 1 only when all the inputs are is equal to 0. If any of the input is having high, finally we are getting output is 0. So only for the NOR gate the output is high when all the combinations are is equal to 0 only. When all the combinations are is equal to 0 only, we are getting the output is high. So this is about our third question. And fourth question, in a 4 input AND gate, the total number of high outputs for 16 input states are, in a 4 input AND gate, the total number of high outputs for 16 input. So then you take 4 input to the power of 4 is equal to 16 AND gate. Total number of high outputs for 16 input state high. Only when all the inputs are high only the output is high. For remaining, it is 4 input NAND gate. You see 0 0 0 0 0 0 1. So like this every combination having 0, only the last combination having all ones. So that according to the AND gate logic, if all the inputs are high only we are getting high, all remaining combinations we are getting 0. So that among 16 we are getting 1 only one time. How many number of times we are getting 1? Only one time. So the output is 1. Answer is 1. And IEEE symbol represent a gate. Which gate? OR gate. Next, NAND gate can be viewed as the combination of the following gates. So NAND gate is the combination of which gate they are asking? AND plus NOT. Is it clear? Once we check the answer, okay, it is correct. Next, NOR. So NOR means AND plus OR. No. NOT plus XOR. No. NOT into OR. So by NOT into OR is there, OR into NOT is there. So OR into NOT is our answer. Okay. Once we check OR, why NOT into OR means first we are taking the OR function, then we are taking NOT function. So next, now tell me, what is XNOR? What is XNOR? XNOR function and NOT. XNOR function and XNOR, not OR and NOT and not XOR. What is XNOR? XOR and NOT. XOR and NOT. Next, draw and explain the symbol to table operation of basic unit. Okay, you draw. So in our examinations, previous examinations, they are asking among Boolean algebra and basic gates. First, they are asking about gates, very important. So in our today's class, gates very important. Basic gates, universal gates, and special gates. So first question is draw and explain the truth table of basic gates. So basic gates means AND or NOT. And in second question they are asking about XOR gate only. And in third question they are asking about NAND and NOR gates. Combinational gates are so called universal gates. Next, fourth question, list all the logic gates. Do you know and draw the symbols? How many number of logic gates are there? All. 3 basic gates, 2 combinational gates, 2 special gates. And these are the expressions. By using Boolean postulates, we will simplify. See here, one example is there, a plus b into a plus c is equal to what we are getting? A plus bc. So a plus b into a plus c, they are taking a is common. So a plus c plus b into a plus c. So finally we are getting a plus b. So you observe these examples and once check. If a is 0, then a bar is equal to how much? 1. 1 only the answer. Okay. Next, a is 1. A plus a b bar is equal to, already I told you. By adding the variable and their complements, we are getting 1 only. If we multiplying the variable with its complement, then we are getting 0. By adding, we are getting 1. Boolean algebra was invented by George Boole. Very good. Next, a into a bar c is equal to, a into a bar always is equal to 0. Okay. So in this way, you do the mathematical expressions by inserting all the laws. Associative law is there, distributive law is there, commutative law is there. Okay. And redundancy laws are there. A plus a b is equal to a plus a bar b is equal to a plus b, and a into 0 is equal to 0, a plus 1 is equal to 1, a plus 0 is equal to a. So like this, by using all the laws, you try to solve the Boolean expressions. Okay, here examples also there. Okay, so this is about today's class. So in today's class, we are going to discuss about what are the different postulates in Boolean algebra, and who invented the Boolean algebra, and how many number of variables are there, how many number of constants are there, and how many number of logic gates are there. Okay, what are the basic gates, what are the combinational gates, and why the combinational gates are called universal gates, and what are the special gates. Okay, so all these are belongs to the basic gates, different logic gates. So which logic is there and which gate symbols, everything is very important. So now I would like to conclude the class.